Hi everyone. If you're viewing this video, it's because no one in your particular class hour had signed up to describe our second term pair of the day, agonists and antagonists. So I will help you through that. These were terms, just like our first pair, that were from our biological basis of behavior unit. These terms admittedly look kind of similar, so that's probably part of the problem. But both of them are used to describe the roles played by drugs or other exogenous substances within a synapse, so in the space between neurons. And this is an important point, some of us were confused about this during our biological basis of behavior unit. This is not a term that's used to describe a neurotransmitter itself. So we might describe cocaine as an agonist for dopamine, or we might describe alcohol as an agonist for GABA, but GABA is not an agonist. It's a neurotransmitter. Dopamine is not an agonist or an antagonist. It's a neurotransmitter. So this is only used to describe the impact of a substance on a particular synapse for a particular neurotransmitter. And that does make it a little confusing. So the diagram that you see on the slide here does illustrate what we mean by these terms. So if this is our natural chemicals, like a neurotransmitter, for example, dopamine, an agonist drug excites the receptor sites for that neurotransmitter. And there's a couple ways that it could do it. It could actually be similar enough in molecular structure that it sits in the receptor sites for that neurotransmitter and then acts as the neurotransmitter. Like the receiving dendrite just treats it like it's the neurotransmitter. So that's going to feel to the person like they have more of that neurotransmitter in their system. So if this was dopamine, and here we have an agonist for dopamine, the person taking that drug is going to feel like they have more dopamine available. It's going to produce more of the impact that dopamine normally would have in their system. Now, there are some agonists that also just produce more of the neurotransmitter. So just there is more being released into a synapse. But regardless of its mechanism, agonists always replicate an increase in the availability of a neurotransmitter. Antagonists do the opposite. Sometimes we use the phrase agonists excite, whereas antagonists inhibit, because an antagonist drug is going to block the normally or naturally occurring neurotransmitter from having its effect, and that's going to reduce the amount available to the person. So if we have a antagonist drug that's maybe similar enough in its molecular structure that it can occupy a receptor site, because it's sitting in that receptor site, the normal neurotransmitter, maybe dopamine or serotonin, can't get through. So to the person experiencing or taking that kind of drug, they're going to feel as though or get the impact of having less of that neurotransmitter available. Also, just like agonists can boost availability of a neurotransmitter just by causing more of it to be released, antagonist drugs can do that as well. They might just block or interfere with the release of a particular neurotransmitter into the synapse, so the person has less of it. So typical examples, cocaine is an agonist for dopamine. So taking cocaine increases people's dopamine levels, and that's why it produces its stimulating effects and addictive properties. Antagonists, because they interfere with normal neurotransmission, a typical example would be alcohol being an antagonist for glutamate, because glutamate is normally an excitatory neurotransmitter. Taking alcohol actually gets in the way of that neurotransmitter doing its job, in part producing the slow responsiveness and numbing effects of the depressant alcohol. So I hope this helped clarify some of these things. Both are names that can be used to describe the functions of drugs, but our agonists increase the activity of a neurotransmitter and antagonist decreases it. And good luck with the rest of the lesson.